Okay, today we're going to be looking at a lot of different circle vocabulary about segments and arcs. I want to I've got those written definitions, but the main thing is more than knowing a formal written definition is if you can identify these things when they show up in a circle. So, for example, a radius, you've heard that one before. That's a line going through the middle of the circle. So, in this case, a radius would be something like this, where you are going across there. There's your radius. The next one you have is a chord. A chord is just any line that goes across the circle, so that would be a chord. This diameter would actually be a chord, and the middle part of this secant would be a chord. Now, the difference between the chord and the diameter is the diameter has to be through the middle of the circle. So this one is both a chord and a diameter, but you could not say that this line over here would be a diameter because it doesn't go through the center. And it is true that the diameter, since it goes through the center, you can see pretty easily is the longest chord in the circle. As we continue moving on, the next thing is a secant. A secant is a line that passes all the way through the circle. Later on, we'll talk about some angles that happen when lines intersect inside or outside of the circle. So the secants will allow lines to intersect outside of the circle. So that part inside the circle is a chord, but the whole thing going all the way through would be a secant line. The next one is a tangent line, and you can see as a secant line intersects the circle twice, once there and once there. A tangent line only touches it once. So the tangent line is the line here. It touches the circle exactly at one point. And it is true that when the tangent touches a radius or a diameter, it is perpendicular there. So if you drew another tangent line right here, it would have to make a right angle with the radius and only touch that circle at one point, right where the radius touches it. It would be 90 degrees. I hope that gives you a good start to circle vocabulary. We'll scroll on down and do a few more examples in just a second. Now, it's important to consider some of these circle properties. First of all, the radius is half the diameter. You've probably used that one before. So, for example, if I had a circle like this and they told me my radius was 4, that means if I had a diameter of the same circle, it would have to be 8. It's also true that any two radii of the same circle are equal. So basically, this half of that diameter is 4, this half is 4, so the whole thing is 8. The next thing is that if a radius and a tangent intersect, they form a right triangle. So in this case, you can basically use this to know that this will be a right triangle if the Pythagorean theorem works. So it says, is AB a tangent to circle C? And when it asks that question, I can say, hey, is 30 squared plus 16 squared equal to 34 squared? And that's where it's probably time to pull up Desmos. And I could just do 16 squared plus 30 squared. That's 1156. And 34 squared is 1156. So that would be a right triangle, since 16 squared plus 30 squared is 34 squared. So this is a right triangle, and since that is a right triangle, you know that this is a right angle there, and if a line intersects a radius at a right angle, it has to be a tangent line. So AB is a tangent line if the Pythagorean theorem works, meaning that's a right triangle, or if you know it's a tangent line, you can use the Pythagorean theorem. That's what's happening on this next one.